Hi, in this video I'm going to talk about some topics from section 4.1, saving money, the power of compounding. So first let's look at simple interest and APR. Simple interest is calculating by applying the interest rate to the principal only, not to any interest that is earned. The formula for simple interest is simple interest equals principal times yearly interest rate as a decimal times time in years. Now an example. Suppose we invest $2,000 in an account that pays simple interest of 4% each year. Find the interest after 6 years. So using the formula, we have simple interest equals 2,000 times 0.04 times 6, which equals 480. So the interest that will be earned on this investment will be $480. Since the interest is only paid on the principal investment, not the interest, we should not expect to see a lot of growth over the 6 years. However, $480 of free money isn't a bad thing. The yearly interest rate that banks report is called the annual percent rate, or APR for short. So consider a savings account where interest is deposited into the account at the end of each month. This 1 month period is called the compounding period. And suppose we have an account with a principal amount of $1,000 and an APR of 2%. We want to figure out how much would be in the account after 6 months. To complete this, we must first calculate the monthly interest rate that we will earn by dividing the APR by 12. So 2% divided by 12 gives us 0.167% of monthly interest. So now we can organize this information into a table, like so. And so in this table we see that after 4 months, we have received about $5.01, and that the interest earned each month is the same. But on the 4th month, we actually gain an extra penny of interest. And so our interest is gaining interest. Let's compare this to simple interest. $1,000 times 0.02 times 0.05, since it's half a year, 6 months, it gives us 10. So over 6 months, from the table we can see that the total amount of interest earned would be $10.05, as where with simple interest we would only earn $10. We see that there's a 5-cent difference with more compounding. Although this may not seem like much now, this will add up over the years. So if we take the exact same account and continue this calculation for 20 years, at the end, the simple interest account would have earned $400 of interest, as where the account that was compounded monthly would have earned $491.33, which is a $91.33 difference, a little more impacting. So one question you should ask yourself is, does there exist a number or calculation that compares accounts that takes into account the number of compound periods and the APR? The answer is yes. This is called the annual percent yield, or the APY. The APY of an account is calculated using the following formula. So the higher the APY, the higher the yield you will receive on an account in 1 year. So let's look at our final example for this video. Say we have 2 offers from separate banks. So the first bank offers an account that has an APR of 1.25% compounded monthly, and another offers an account with an APR of 1.2% and is compounded daily. Let's see which is the better savings account. So see here we have Bank 1's APY plugged into the formula, 12 for N and 0.0125, that rate is a decimal, goes through the formula and gives us 1.257% APY. So for Bank 2's APY, same concept, except since it was compounded daily, we used 365, and it had an APR of 1.2%, so that as a decimal is 0.012, and so that becomes 1.207. So here we see that even though there were more compounding periods from Bank 2, we still have a higher yield from Bank 1. Now, this will not always be the case. Sometimes more compounding periods would give a higher yield. And one final thing to note about APY is that it is calculated for a single year. APY does not take into account how long it takes for an account to reach maturity, only the percentage that the account will yield over 1 year. So as always, my name is Ethan Smith, and if you have any questions, please feel free to reach out to me. My email address is esmith845@cvcc.edu. Again, that's ESMITH845 at cvcc.edu. Have a good day.